The overall conviction among most scientists is that the hypothesis of how things came to be stays the major explanation for the early seasons of the universe. This speculation joins the movement of stars, planets, and so on, including life on those planets, including ourselves. Not persevering through its odd name, the Big Bang, it offers an illuminating appraisal concerning what could have happened at first. The universe was thick in a short space, more thick than a pinhead with particles thickly packed. From this second, a giant impact of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the spreading out of huge history. In any event, in intelligent data, we have set off developing inconsistencies with the suppositions of this hypothesis. When NASA shipped off the James Webb Space Telescope, the largest and most advanced space science observatory of all time, analysts assessed that its acumen would confirm the hypothesis of the universe's starting point. Tragically, after only 1 year in space, the telescope astounded specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's stunning limits have uncovered endless systems going as far back to a time so old that it challenges how we could decipher the universe's beginnings. This revelation has sparked an intense appraisal concerning what existed before the Big Bang. One critical moment in this mission occurred when cosmologist Rohan Natu, working with data from the telescope, suddenly tracked down a system from just a short time frame after the Big Bang, making it the most distant universe of all time seen. Natu's revelation sent shock waves through established specialists, highlighting the amazing capabilities of the James Webb Telescope. Its gigantic objective to change our perspective on the universe has only scarcely begun, promising to reveal dazzling insights into the earliest times of the universe's existence. This period, barely concentrated ahead of time, holds the key to understanding the development of the first stars and galaxies. The telescope's disclosures have conflicted with fundamental theory, uncovering galaxies with attributes outperforming past assumptions. This extraordinary surge of early galaxies has ignited a storm of scientific inquiry, testing specialists to accommodate these discoveries with existing theories. As researchers grapple with these revelations, they face key questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advancements, which are obvious, it is located 1.5 million kilometers away from Earth, shielded from standard obstruction and cooled to approach absolute zero by its tennis court-sized sunshield. The telescope integrates a gigantic segmented mirror and unbelievably sensitive instruments, designed to uncover details of the early universe previously secret. This period, known as the Cosmic Dawn, happened around 200 to 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of perfect examination, with theories ranging from the impacts of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they could decipher these complex elements. By researching these ancient galaxies, researchers can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. Initially, the telescope was supposed to observe a few weak and small galaxies in its pilot studies. However, reality has far surpassed these expectations. The telescope's early pictures of the distant universe revealed an abundance of galaxies with ages, sizes, and brightness levels that challenged all predictions. This astonishing flood of early galaxies has ignited a race among space specialists to establish new benchmark records for the earliest known cosmic systems, with new discoveries arising constantly, leaving mainstream experts in awe. Following the James Webb Telescope's revelations, topic specialists and observers have raced to concentrate on the existence of these shockingly advanced early galaxies. Some speculated that errors in the telescope's interpretation of vast observations could be responsible for these alarming discoveries. That said, the consensus remains that these discoveries represent a paradigm shift in how we might interpret the early universe, offering exciting glimpses into the potential for incredible progress. The new discoveries from the James Webb Space Telescope concerning galaxies have raised central questions about the nature of the universe and challenged the assumptions of mainstream cosmological models. While certain experts are examining whether these insights can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more complex and puzzling than previously imagined. The key question in play is our fundamental understanding of how the universe we know emerged from primordial chaos. The early discoveries of the JWST could reshape our fundamental ideas of cosmic history, revealing insights not only on distant galaxies and ancient structures but also on the very nature of our own Milky Way. As Mark McFan, senior researcher for science and exploration at the European Space Agency, puts it, "You build these machines not to confirm theory but to break it. You just have no clue how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At that time, G. Weir, then head of STSCI, was tasked with imagining what could come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to see in the infrared spectrum, allowing it to peer much deeper into the universe. This ability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its enormous, cold, star-like mirror, the JWST became the premier instrument for uncovering the mysteries of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation uncovered countless galaxies in what was once thought to be an empty patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much deeper into cosmic history. After 20 exhausting years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most vital year of scientific observations. Early initiatives, such as the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far outstripped them. JWST observations have tested existing models of the early universe, uncovering galaxies that challenge conventional cosmological assumptions. These remarkable discoveries highlight the importance of pushing the boundaries of scientific inquiry and underscore the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to analyze JWST data, they may uncover further insights that test and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists were eagerly anticipating the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which often takes months, specialists chose to share their findings on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed for a new form of peer review to take place through social media platforms like Twitter, where established experts could quickly discuss discoveries. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both unprecedented and extraordinary. However, there were concerns about the potential drawbacks of this rapid spread of results. Klaus Pontypool, a JWST project researcher at STSCI, warned that while the quick sharing of results facilitated fast dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most specialists is that the hypothesis of how things came to be remains the central explanation for the early seasons of the universe. This theory incorporates the development of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang provides a compelling explanation for what could have occurred at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with tightly packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up the unfolding of vast history. However, changes in scientific knowledge have led to developing inconsistencies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, experts estimated that its observations would support the theory of the universe's origin. Tragically, after only 1 year in space, the telescope stunned experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's striking capabilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's beginnings. This discovery has sparked intense examination about what might have existed before the Big Bang.